Hello everyone, this is DSA Zindabad. Today we are going to solve the fifth question of our Goyal DSA sheet. The question is move zeros. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making a copy of the array. Now let's look at the example. Let's say we have this example 0, 1, 0, 3, 12. So what is our main goal? To move zeros to the end of the array, right? So data array will something like this. In this, we are moving 0 to the end of the array, right? While maintaining the relative order of the non-zero elements, which means one should be to the left side of the 3 and after 3 we'll have 12. We'll maintain the order of our final array as it was there in the input array, right? Now let's look at the second example. Since there is only one element, so its answer will be same as that of the input array, right? So now let's jump into the approach. First of all, we are going to discuss the brute force approach. What does the brute force approach say? Brute force approach says we are going to need two different arrays. First is for storing non-zero element and second is for storing zero element, right? Let's say we have this array 0, 1, 0, 3, 12. So non-zero elements will be present in this array. First of all, we'll traverse over this array and store all the elements which are non-zero in this array and all the zero element in this array. And at the end of this, we are going to combine this array into a single array and then overwrite all the results into our input array, right? Now let's discuss the time and space complexity for this approach. Time complexity would be big O of n since we are just traversing over the array again and again. And space complexity would be big O of n since we require two different arrays. But this approach is time intensive, but not space intensive, right? So is there a way to reduce the space complexity of this problem? Yes. And in fact, in the question, it is mentioned that you must do this in place without making a copy of the array, right? Now let's discuss the optimized approach for the same. So when we have a array and there is this condition in place, what comes in our mind? Pointer approach, right? Because there is only this way with the help of which we can traverse over the array without taking any other array, right? So we are going to use two pointer approach. Why two pointer? Because we need to keep track of the non-zero and zero element, right? This is the main reason why we are taking two pointers, right? Let's say we have this array 0, 1, 0, 3, 12, right? 0, 1, 0, 3, 12, right? And we'll have two pointers. One is non-zero and one is zero. So initially, both of the pointers will be pointing to the start of the array and non-zero. Now we are going to traverse over this array linearly. Now, when we find that non-zero is equal to zero, then we are going to increment our non-zero because non-zero pointer will be pointing to the non-zero element. So after this, our non-zero will be pointing to non-zero element, right? And 0 will be pointing to the 0 element. Non-zero is not equal to 0, right? Now, after this, whenever we found that non-zero is not equal to 0, what we are going to do? We are going to swap these two elements, right? Now 1 will be there and 0 will be there. Now, when we are doing the swapping, now we need to increment both non-zero as well as our 0 pointer. Since 0 is not pointing to 1, since 0 is not pointing to the 0 element, so we'll increment our 0 pointer. So 0 will be pointing to this and our non-zero will be pointing to this. Now again, since there is 0 over there, so we are going to increment our non-zero. Now, as we can see, like non-zero is pointing to the not zero element. So we are going to swap these two elements. So 3 will be there and 0 will be there. Now again, increment our 0 as well as non-zero element. Now at this point of time, non-zero is pointing to the non-zero element. So we'll again swap the two elements. So 12 will be over there and 0 will be there. So at the end of this, now again, after this, like since there is no array over after 12, so we are going to stop at this point of time, right? Now, as we can see, like our array will become something like this, which is our answer, while maintaining the relative order of all the non-zero elements, right? So two-pointer approach works in this way. I hope this approach is clear to all of you guys. Now let's try to code this thing up. So this is our question. Initially, we'll be having two pointers, which will be pointing to the start of the nums array, right? And we'll be having right, and will iterate until our non-zero is less than that of the size of the nums array, right? Whenever we find that if nums of non-zero is not equal to 0, what we are going to do? We'll simply swap that side nums of nz and nums of z. Side by side, we are going to increment our node 0 pointer as well as 0 pointer. Else, simply we just increment our non-zero pointer, right? Now let's try to run this code. This is passing for this test case. Now let's try to submit this thing. Yeah, this code runs perfectly fine. Now let's discuss the time and space complexity for this. Since we are just creating two pointers, so it will require big of one time. And as we are traversing over the array, it will require big of n time. So ultimately its time complexity would become big of n and space complexity would be big of 1 since we are not using any extra space, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please like, share and subscribe and comment if you have any doubts. Thank you so much.